This is a video on how to use the TI-84 on an AP calculus test. So there's 4 things that you're allowed to do with your graphing calculator. 1, plot the graph of a function within an arbitrary viewing window so you can see what the function looks like, graph the function. 2, find the zeros of a function. So find where a function crosses the x-axis basically. Step 3, numerically calculate the derivative of a function. And 4, numerically calculate the value of a definite integral, and we'll be doing all 4 of these in this example. So here's a TI-84, and so from this kind of goes along with our first notes on 6.2 on find the area between two curves. So you should follow along and come to this and see how you do this. So we have to first program our equations. So that's what I'm going to do first. And so kind of I will use a mouse and a pointer. So right here, y equals. If you hit that, that's where you store all of your functions. Okay, so you will hit that and you have up to 10 functions. So our first function is ln of x plus 2. So ln is right here. I'll hit that. Your variables are always here. Always. Just hit that for your variable. Automatically puts it in. Close up the parentheses. Plus 2. I think you all can get that. And then hit the down arrow here to get to the next one. And that one's going to be e to the x. E to the x is the inverse of ln, so it's the blue function, the second function. So I have to hit second and then ln of x to get me e to the x. And the variable, again, is x here. So you always hit this button here to get your x. And there we go. Now the window, you have to choose your starting x value, your ending x, your minimum y, your maximum y. So that's kind of the window of your graph. The x scale, excuse me, tells you how often you put a dash. Is each dash worth 1, 2, 3, 5, 10? Same thing here. And those are the only things you really need to worry about on this. Now, from that example we had before, I'm going to go from -1 to 3, actually -2 to 3 on all of these. So very important. This is negative, this is minus. They're not the same. If you interchange these, you will not get the right answer and you'll get errors. So negative is here, so -3. Hit the down arrow, and then up to, actually I wanted -2. Let's go back up. -2 to 3. I'm going to do the same thing on the y, -2 to 3. And the graph button, here's how you graph. All these have to do with graphing. Well, not all, but the bottom functions, graphing or tables. So I'm going to hit graph, and I didn't put it in right. Let me go back, sorry. Yes, this is supposed to be e to the x -2. So I'm going to get my right arrow to get to the end of that, and I can add my -2. Forgot that. Back to graph. That looks like the graph from our example. Well, we found the intersection. And you might say, well, the intersection wasn't one of the 4 things we're allowed to do. Well, the intersection is when, excuse me, these two are equal. And so basically, if you subtract them, equals 0. So technically, what you should be doing is I'm going to hit the down arrow, and I'm going to subtract these 2 functions. Now, the ln's bigger in our graph, so I'm going to do y1 minus y2. Now, 2 ways to get to y1 and y2. Those are variables. So I can hit the var button right here. And what kind of variable? It's a y variable. So I'm going to hit my right arrow to get to the y variables. And it's a function, so I'm going to hit 1. And I'm going to put y1. I want y1. So I can enter or hit 1. So it's going to be y1 minus, and I'm going to do the same thing, vars. I want a y var, so I'm going to hit the right arrow to get to y var. And it's a function, so I'm just going to hit enter this time. And I want y2, so I'm going to hit the down arrow and enter. So y3 is y1 minus y2. It's the difference between those two graphs. Okay, so I don't want to graph y1 and y2, so I'm going to use my arrows here to get on top of the equal sign there. And if I hit enter, you'll notice it's no longer highlighted. That means it's no longer going to graph it. I'm going to hit enter again. Since those top two weren't highlighted, it won't graph it anymore. And now when I hit graph, it graphs the difference between those two graphs. And now you can find where it equals 0, because that was the two places, right here and right here. So that's how you could do that. I'm going to show you how to find these zeros, because that's the one of the 4 things you're allowed to do with your graphing calculator. So up here has mostly to do with graphing situations, but this calc you see here, that calc is calculations about your graph. And since it's blue, to get to blue things, I have to hit the second button. So I'm going to do second calc. And these are the things your calculators will do. Find the value of your function at a point. Find the zeros. That's what we're trying to find. It'll find the minimum and maximum of your curve. You're not allowed to use this to find min and max. You have to use our chapter 4 techniques. Or where two curves intersect. I actually use this because this is equivalent to a 0. Because that means when you subtract the two functions, they're equal to each other. So you're allowed to, I allow you to use intersect, which is basically finding the 0. You can find the derivative here or the integral, but I would not do it on the graph here. I would do it on the home screen. So I'm going to do 0, so I'm going to hit 2. Read the screen. Left bound. So we have two zeros, this one and this one. We're going to find this one first. The left bound means put this dot to the left of this intersection. You can use your right arrow here to move your blinky bob, I like calling it. Or, so I'm going to put it right there. That's left of it. I'm going to hit enter. Down here, hit enter. Now it asks me, what's the right bound? Well, I need to put this blinky bob to the right. Now instead of hitting the arrow here, which I could, to put to the right, you can actually punch in a number. This is 1, that's 2. I'm going to put 1.8. So instead of hitting this a bunch of times, I'm just enter 1.8 and hit enter. And it puts the blinky bob there. Now it says guess. I'm going to put my blinky bob. Now, the reason it says guess, it wants to know which one you're talking about. Is it this one, or is there another one? And so as long as this blinky bob is close to it, you're okay. If there's no other one around it, you don't have to get any closer than that. If you want, you can get right on top of it. But I'm just saying, if you want to save some time, you don't have to get right on top of your intersect. I hit enter, and I get a 0. That's where the subtraction of the two functions are the same. Now remember that, 1.4797. I don't know if you can, that's the same number, hopefully, as I put on the other video. Now we're going to do the same thing, and you guys should be practicing this on your calculator just for experience. Second calc, I'm going to do 0, left bound. Okay, I'm going to move this dot, make sure it's left of that 0. That's left of it, there. Hit enter. Then it says, what's the right bound? So I'm going to move it to the right. That looks right of it. I'm going to hit enter here. And then it says guess, so I'm going to move it closer. That's pretty close. And there it is, 0.54 or 0.052547. Okay, now I wouldn't do that. I showed you that because you're allowed to find zeros, and you need to find zeros on the test. But in this one, here's what I would do. Re-highlight this one. Re-highlight this one. Don't highlight that. I would just find where these two intersect. I'll explain. Let me graph these again. So where these two intersect right here, the subtraction, the difference of them is 0. That's when I graphed the difference. It was 0. So when I found the 0, I was finding this point. So I'm going to find this by using a different technique, which saves us time. So I'm going to do second calc again, and I'm going to do intersect 5. So I'm going to hit 5. Now let's read. It says, what's the first curve? Is my first curve the blue one? Yes. So I'm going to hit enter. It's asking, what's your second curve? Is it this red one where the blinky bob is? Yes. Why is it asking me that? Because if you have more than two curves graphed, you're going to need to specify which curves you're trying to intersect. I'm going to hit enter. And then this is guess. So same thing. I'm going to put this, whoa, right about there. That's a good guess. And you'll see this is the same number as before. Now, I don't want to memorize that. I don't want to take a chance of writing that down incorrectly. So I'm going to store that as B. Remember, as A was the left, B was the right. How do I store that as B? I need to go to my home screen by doing second quit. So I'll do that. Second quit takes me to home screen. And then I want to store the X value I just found. So I hit X. And then I'm going to store that. So this button down here, store, will store where I want to. And then I have to pick a value. I want an A. How do I get to this green A? Alpha A, and enter. Now that number I just found was stored as A. Actually, I wanted it as B, so let me really quickly do this. X store alpha B. That number will stay in as long as nothing gets changed. It actually will get changed. I'll explain that to you in a bit and why I stored it as B. Now let's go back to our graph, hit graph here, and second calc. And I want to find the intersect again, so I'm going to hit 5. First curve, let me move over. Is the first curve the blue one? Yes. Enter. Red one? Yes. Enter. Now guess. I'm going to move it close to that second intersection point. Hit enter. There it is, 0.052547. Now I'm going to do second quit and save that as A. Second quit, X, store, alpha A. Enter. So those are now stored in the calculator. I don't have to memorize them. I can bring those up whenever I want to. And it works out well. So that's why we store those, so we don't have to write all these numbers down and have a chance of incorrectly entering them. Now, a note about X. X is used by the calculator. So think about all these storages. X, Y, A, B, C, D are lockers. You place things in the locker to save them. We're placing numbers. Now, stored in locker A is this number. Now, I had this number there, but when I stored X and A, I took this out and I replaced it with this. So it will stay there as long as I don't change it. But X and Y are lockers that are used by the calculator, and the calculator will move things in and out of there. And so you got to be careful and don't assume what's going to be in those lockers. You have control of all the lockers A, B, C, D, but you don't have control of locker X and Y. So be careful about that. Now I'm going to clear. And how do you find an integral? Because that's one of the other 4 things you can do. So under the math, right here, you hit math. You can find, change things to fractions, but here are the things you want. The derivative or the integral. I'm going to hit number 9. You could go down to 9 and then hit enter, but it's faster just hitting 9. And there's your integral. Now, if you have an older calculator, it might not look like this. I'll need to help you with that. If you have a TI-84 and it doesn't look like this, you can upgrade it to look like this. And you have to ask me about that. But I'm going to integrate from A to B because those are the values I had. So this is what's beautiful about storing it. I do alpha A, right arrow, alpha B. Those numbers I saved, I don't have to enter those. So much easier. Then, what am I integrating? This is my height, and that's going to be y1 minus y2. So remember how I went to vars? There's a shortcut. Instead of going alpha, vars, y vars, function, if you hit alpha, trace, you get right to those variables. So we're going to do y1 minus alpha, trace, down arrow, 2. Here, our width is dx, and hopefully I got those in the right order, else it's going to be about negative. Let's check and make sure. There we go. It integrated it for you, and you'd have to show this on your paper and this answer. That's how you do integrals. And while we're at it, let me show you derivatives. It's just as easy. You just do math. It's going to be number 8 for derivatives. It's with respect to x, so I hit x, and I will do of the first function, alpha, I'll do of y1, and we'll find the derivative at what point? We'll say at 2. I hit enter, and that's how you find the derivative of a function at a specific point. That's your format. And that's a rough introduction. I'll throw a few things out at you, bonus things. If you do alpha y equals, you can get a fraction. Very nice. Instead of that slash, you know exactly what's on top, what's on bottom. There's some other things available to you. We could actually experiment and look around. You might want to play around and see what happens here. Oh, here's some math functions, absolute value, and derivative. So there's a shortcut there. Let's find here. That's for matrices. That's, we already know. What's that one give you? So you can kind of play around and see what these things give you. Not seeing anything there, but that's kind of it for this video.